Z nami je dr. Hend Mahgoub, prihaja z Univerze v Ljubljani z Fakultete za kemijo in kemijsko tehnologijo, kjer je podoktorska raziskovalka v laboratoriju za dediščinsko znanost. Ima končano računalniško fakulteto ter magisterij in doktorat iz dediščinske znanosti na University College London. Interdisciplinarno sodeluje in se aktivno vključuje v mednarodne projekte na področju znanosti o dediščini. Trenutno z Dukom tesno sodeluje v okviru projekta Ancient Book Crafts, ki razvija in validira metode datiranja z uporabo infrardeče spektroskopije za gradivo na papirju in pergamentu. Dr. Hend Mahgoub, please, the microphone is yours.
Okay, thank you so much for the introductions. Hello, everyone. Thank you for having me today. As you said, I'm going to speak about ABC project that I'm involved in. Okay, so Ancient Book Crafts is a project, European project. It's mainly work with advanced techniques for dating archival materials, and it is funded with through WEAVE program in collaboration with the Science Fund FWF from Austria and the Slovenian Research Agency. And we work with many institutions in both countries, in addition to collaboration with the National Library in the Czech Republic as well. So I will skip, one second. I will skip my introduction because I guess you already introduced me and you know my background. So talking about the project directly, it's mainly worked with the spectral measurements from materials, focusing on three types of materials in the archival books, which is leather, parchment, and paper. And the main target is to construct or to develop like a date model or date methodology to date some books that are not having an accurate date in the libraries, using a non-destructive technique like spectroscopy. So firstly, why we need to date a book? So we have thousands of undated paper, documents, manuscripts, and books preserved in the libraries. And the golden question there is it authentic? Is the written date is the true one? So everyone is looking at the books, trying to understanding it. So understanding an archival material is strongly attached to their material history, how they were produced, and all of this information is attached directly to the production date. So knowing the date of the object will complete the story and give the narrative that we are saying about the book an evidence, a scientific evidence. So let's do it. How we can do this? Researchers have adopted many methods in the libraries, like we are looking at the support, like parchment, paper, papyrus, trying to get remarks on the paper, watermarks, the chain and blade lines in the paper, the stamp motifs, binding the style, how we writing, types of pigments that have been used, and also what is the history have been written for the provenance of these books. But sometimes these techniques have some limitations with the materials. So although that, as an example, watermarks, we could reach like 1 year gap if we have watermark in each book. But this is started when the watermark have been started. So the other books are not into this technology. If we look to other techniques as well, it have been adopted from one country to another, to some overlapping in this. So there is not accurate information that we can get. So we need like a scientific method that can complement the story or make an evident for what we got from these techniques. So one of these techniques is radiocarbon dating. It's one of the famous techniques for dating, and it is used with a lot of materials as well. But it is destructive, expensive, and needs a lot of materials to do it. And sometimes it has some limitation with some samples, and it needs preparation for the samples, which could have been contaminated and damaged. So it's not really worth with all the materials that we in archives that we can face to get a date for. So as an example for this charter document from National Archive in Netherlands, usually the objects there are dated from the 12th to 18th century. This charter have been given two dates there. It's 1314 or 1469, and they couldn't really have I guess which one of these is the true one. So using the spectroscopic technique and infrared, some researchers did so and have this dating prediction, and they said that it is nearly into the 1314 more than the 1469. And this was actually proved with written text. It was the early 14th century. So this is an example of how both techniques complement each other. So this is what we do. The spectra can get from different devices, and it holds information from the paper, from support, parchment, whatever the material. It is portable, non-destructive, rapid, and can be in situ. So we go to the library or the archive and take the information from the books collected, and it used in different applications for characterization, identification, dating, monitoring degradation, and different applications as well. So how we can do this in our ABC project? First we have to collect reference collection. Like we go and say we need to predict the date of some books which range from 12th century to 18th century. So we need to get a data set of books from the library, well dated with the metadata from this range of time, and we get the dates, measure the spectrum measurements from these data sets, and we build a calibration methodology using statistical methods and some machine learning methods. And then we go with our tool to measure the undated book with this get the spectra for the unknown sample, and then we predict the date according to the model. This is simply the thing. So first step is we have to get the reference collection, the well-dated reference collection. So in ABC, we have 3 different materials: paper, parchment, leather. So we work with Nook, and we have built, we selected 100 well-dated archival paper objects with their metadata, and they covers from 15th century to mid-19th century, and we carefully selected them to have like an even representation for the dating range, as you can see. And then we have measured thousands of spectra. As you can see in the picture here, we have the book, different pages in the book itself, and then in the same page, we have different locations for the spectra, so we have an overview through the book and through the page as well. For the parchment as well, from Nook, we have around 150 samples, and it is somehow distributed, but it's hard to get like a well-dated from the same range that we want to date. So we have equally distributed samples, but we need to fill some gaps in between. And these gaps have been filled with our partner in Austria, Klosterneuburg AP. They have charter documents with the dates, dates written on them. And then they, like 100 of them, they fill the gaps in the same period of time. So we will integrate both databases, and we will build our model for the dating. And in the parchment, we can see that we take also different measurements from the whole parchment and from back and verso and recto of the object. For the leather, we don't have samples here from Slovenia. We have from our partner in Austria as well. They have 100 objects from leather, and they covering from 15th century to 19th century as well. We got our reference collection, and then these are the techniques that we are using to collect the spectral measurement. So this is FTIR and near infrared. It's simply a device that is just contact with the paper. It collects a sort of a spectra or sort of numbers in each band from the electromagnetic spectrum, and it gives us an idea of what this represent the production date. So we take this from each device, and you can see that the shapes of each of one is different than the other one, and although they are from one book, they look different because they hold the same information but in different ways, and they see, as each technique have its own specification, they see differently with the penetration from the book. But our role now is to process this data, build a program to prepare the model, and extract or interpret this information, try to find the correlation between the dates that we have for the books and the spectra in our hands, and merge together, get the idea which are the bands that are representing these dates. And then when we get the model with a specific accuracy, we can have a date to predict the other set that we are preparing to validate our model with. And we have like transfer this model between Austria and Slovenia to be able to test our model in different countries and under different storage conditions as well. To put this in context, these techniques already have been tested before with different materials and different types of paper and parchment, and they use the same technology, and they have good accuracy and approved success. Recently, the last year in 2023, in our groups, Floriana Capola, our colleague, have been working with the same technique on advanced techniques on the European paper, but on the modern range from 1850 to 2000, and they could reach like 2 years accuracy of this prediction, which is significant in our science way, because it could lead to a good guess between decisions that when we have a problem, is it from this year or this year? This accuracy is quite good for prediction. And then we aim, we are in the stage we are now, we are building the models. We have finished collecting the spectra from the book paper collection, halfway in the parchment collection, and we finished with the leather as well in Austria. So now we are building the model and validate them to start doing the prediction in situ in the museum, in the libraries as well. So I give you an overview about the project, and hopefully this was not hopefully is this clear enough. And if you have any question, please go ahead.
Dr. Mahgoub, thank you very much for your presentation. This was very interesting. I don't see any question in the chat. So I just wish you all the best with your project in the future.
Thank you
very
so
good
much.
Results.
Thank you. Okay. Have a nice day. Bye.
Yes, thank you very much.